Okay, here's a trig modelling type question. We're going to do it using the GDC. I'm going to probably draw a small sketch just for working out, but we could potentially do it without. The peak height, h meters of ocean waves during a storm is given by the equation h equals 9 plus 4 sine t over 2, where t is the number of hours after midnight. Right, so t equals 0 happens at midnight. An alarm is triggered when the peak height goes above 12.5 meters. Find the value of t when the alarm first sounds. So if we can have a look at this, it's quite handy because if we were to just solve h equals 12.5 and we didn't have an idea of how the trig function worked, then you might give the wrong answer because it could be that after that time the height actually goes below 12.5 and not above it. So it's really quite handy to see the graph in this instance. So we're just going to plot the graph of y equals 9 plus 4 sine x over 2. So delete any old graphs that are there. So y equals 9 plus 4 sine. I have quite an old calculator, so I'm going to put x divided by 2. Make sure it's in a bracket. You should, if you've got a decent calculator, you should be able to put x over 2. Again, make sure you use the bracket. Okay, draw, and we're going to have to adjust the window significantly. So the x min and max, well, we guess x min at 0 is absolutely fine. For the max, well, we don't really know how many hours this is going to take, but hopefully we'd assume it's going to be less than a whole day. So I'm going to put my x max as 24 hours, but that's even probably quite generous. So my y min, I'm not expecting there to be any negative height of ocean waves, so I'm just going to have a height of 0, the min. The maximum, well, I just need to make sure that I go as high as 12.5, so I'm just going to go up to 13. And if it doesn't look right, we'll change it, but that looks pretty good actually. So we've got 2 cycles in there, and I am going to draw a little sketch. And it doesn't have to be perfect, but it needs certain things to be in there. Okay, so we've got 2 cycles. Something like that. We went up to 13. This is h and this is t, and we went up to 24. Could put the units, but we've not really been, the marks don't really come from the graph. Maybe a little bit just to show working, but the mark comes from understanding the question and getting it right. H was in meters. Okay, so we are interested in when the peak height of these waves, so remember h is the peak height, when it goes above 12.5 meters. So we're going to need to draw the line h equals 12.5 or y equals 12.5. Okay, so you can see here we go above here, and then we go below again, and then we go above and below again. So we're interested in, the question says, the alarm's triggered when it goes above 12.5, find the value of t when the alarm first sounds. So I want to know when is the first time that happens. If we just draw this line, so that is h equals 12.5. We are interested in that point there. So we're looking to find the intersection. Shift G solve, intersection. And the first one, maybe if I'd have made my y max a bit higher, it'd be clearer what I was looking at, but I'm fairly confident that I'm looking at the right thing. So this happens when x is 2.13, and y is 12.5, as you would hope it would be. Okay, so T equals 2.13 hours after midnight, right? So if you don't like that, and I don't particularly, I've got a bit of an issue with decimal time, so you may want to change that. So if we just go into the main calculator and do something, if we go to option and angle, so if I just put in the number 2.13, I probably should have kept a bit more accuracy, but never mind, and just go to this arrow and DMS, that just converts it to degrees, minutes and seconds, which you can think of as hours, minutes and seconds. So that's saying 2 hours, 7 minutes, 48 seconds. So I'm just going to round at maybe 2 hours and 8 minutes after midnight. So you could call that 8 minutes past 2 in the morning, something like that. That's when the alarm will first go.